It's time for Maths with Mr. Thomas.
Well, howdy, partner. Here we are with Chapter 10, Lesson number 3, the general equation of a circle. Now, if you remember last lesson, we were looking at the equation x minus a all squared plus y minus b all squared equals r squared, and that represents a circle with the centre AB and the radius r. Now, if we take this funky formula here and we multiply it all out, we will end up with another equation, and that equation will be of the form x squared plus y squared plus 2gx plus 2fy plus c equals 0. Obviously, you will not get that if you multiply it out, but you will get something of that form. So you will have an x squared term, you will have a y squared term, you'll have an x term, but what I'm going to do is I'm going to call the coefficient 2g. I will have a y term, I'm going to call the coefficient 2f, and also if I subtract r squared from both sides, add it to whatever constant is here, then I will have a constant as well. So I'll just have a number on its own, and that will then equal 0. Once you are at that stage, or if you are given the equation of this circle, this is known as the general equation of the circle. And it has the centre negative g, negative f. So remember, the g and the f come from the coefficients of x and y. And what you'll notice is that if you take the coefficient of x and you halve it and you change the sign, you will end up with the x coordinate of the centre. And if you take the coefficient of y, if you halve it and you change the sign, you'll end up with the y coordinate of the centre of the circle. So that is how you can get the centre. What we also need to do though is we need to get the radius. And the way you get the radius is you will need these values of g, f and c, and then the radius is the square root of g squared plus f squared minus c. If you are wanting more of a proof on this, please just ask me in class. But this is how you would get it. A couple of other notes that you need to remember is that if you have the square root of g squared add f squared minus c, well, obviously you will have to have something that is bigger than 0. So the expression g squared plus f squared minus c must be greater than 0. If it's not, well, either you'll end up with the square root of 0, which is 0, meaning the radius of the circle will be 0, which makes no sense, or you will end up with the square root of a negative. And again, you can't get the square root of a negative, it makes no sense. So g squared plus f squared minus c must equal 0 in order for it to be a circle. Also, you will notice you have x squared plus y squared. The coefficients of x squared and y squared must also be equal to 1. Sometimes, though, you may get something else. You may get 7x squared plus 7y squared, and if you do get that, you will divide every single term by 7 to begin with to get x squared plus y squared. So the coefficients must be equal to 1, and they also must be equal. Let's try some examples then with that. So example 1. For the circle x squared plus y squared minus 4x plus 8y minus 1 equals 0, find its centre and radius, and then write down the equation in that form. X minus a all squared plus y minus b all squared equals r squared. So the first thing to do with this is to think, right, well, I've got the general equation of a circle. So first of all, look at the coefficient of x. The coefficient of x is 2g, so you can state that 2g must be equal to negative 4. It's just the value in front of the x. After that, 2f is the coefficient of y. So in front of y here, you've got 8. So 2f must be equal to 8. And c is just the number on its own. On its own, you've got a minus 1, so c must be equal to negative 1. After that, if you have 2g and 2f, well, you can halve both of them. So you can find out that g would be equal to negative 2, and f is then equal to 4. So that way you have the values of g, f, and c to work out the radius and also the centre. Remember, the centre is given by negative g, negative f. So the centre then of that circle, you would have negative 2, which will then mean that's positive 2. And you will have negative f, which is negative 4. So that will be the y coordinate. So the centre of that circle is 2, negative 4. R, the radius, it is given by that formula there. square root of g squared plus f squared minus c. You will then sub in these values for g, f and c. Woo! Let's do that. So you've got the square root of negative 2, that's g, squared, plus f is 4 squared, and c is negative 1. So you're taking away negative 1, meaning then that will become plus 1. So that gives you 4 plus 16, and then as I said, that is plus 1. The square root then, it will be the square root of 21, and you would just leave it as the square root of 21. You could always write that as a decimal, but you are far better leaving it as an exact value. If it was a surd, you would simplify, you could simplify, you would simplify it, but we can't, so we just leave it as root 21. We are asked to write down the equation of this circle in that form, x minus a all squared plus y take b all squared equals r squared. So for this one, you would have x take away 2 all squared, plus y take away negative 4 all squared, which is y add 4 all squared, and that would equal r squared. Now r is the square root of 21, which means then that r squared would equal the square root of 21 squared, which is 21. And that is what you would get for example 1. Example number 2. Explain why x squared plus y squared plus 2x plus 4y plus 9 equals 0 is not the equation of a circle. Yes, it is! No, it's not. Because it says here to explain why it's not the equation of a circle. But it is! Well, let's go through this and find out. First of all, again, start it the same way. So write down the coefficient of x as 2g. So 2g must equal 2. 2f is the coefficient of y, so 2f must equal 4. And the number that's on its own is just 9. So c must equal 9. From there, half the values of 2g and 2f, and you then have g to be 1 and f to be 2. So we've got the values then of g, f and c. From there, well really we're asked to prove that this is not a circle. Yes it is! Well, keep going through this, okay? Think about the centre of the circle. So the centre is given by negative g, negative f. So in this case, you'd have negative 1 and then negative 2. So that would be the centre of this circle, if it existed. But it does! Well, keep going through this. See what you get. So from that, think about the radius. The radius is given by the square root of g squared plus f squared minus c. Subbing in the values of g, f and c, you'd have 1 squared plus 2 squared minus 9. It's the square root of all that. Which means then you'd have the square root of 1 plus 4 take away 9, which is the square root of negative 4. Exactly. Why is this not then the equation of a circle? Go on, tell us, Erin. Good, because you can't get the square root of a negative. Excellent. So you can say then that the square root of negative 4 is not a real number. And so this is not the equation of a circle. So that's how you would prove that it's not. It's not! Exactly. Example number 3. For the circle 3x squared plus 3y squared minus 4x plus 8y, take away 1 equals 0, find its centre and radius. Mary Lou, what are you thinking straight away? Good, you have coefficients of x squared and y squared. The coefficients of x squared and y squared must be equal to 1, but in this case, they are not. So, the coefficients, they must be equal to 1, so how would you get 1? What would you do? Absar. Good. Divide every single term by 3. If you divide every term on the left, every term on the right, then that will remain equal. So do that. So start by dividing through by 3. So if you do that, you will end up with 3x squared divided by 3, which is x squared. 3y squared divided by 3, which is y squared. Negative 4x divided by 3, which is negative 4 thirds of x. 8y divided by 3, which is the 8 thirds of y. And the negative 1 divided by 3 is a negative 1 over 3. 0 divided by 3 is still 0. From there then, we have it in that form. We've got x squared, y squared, we've got a coefficient of x, coefficient of y, and a number on its own, and that equals 0. So from there, you can write down these values of 2g, 2f, and c. 2g, remember, is the coefficient of x, so we'd have negative 4 thirds. 2f is the coefficient of y, so we'd have 8 thirds, and c is the number that's on its own, which is negative 1 third. Again, from there, half 2g and half 2f. So you know then that g on its own would equal, we've got negative 4 thirds divided by 2. which would give you negative 4/6. And remember, 4/6, you could simplify that to become negative 2/3. From 2f to go to f, again, you would divide by 2. So if you divide the 8/3 by 2, you're really putting a 2 in the bottom line there. So you'd have 8/6. And remember, 8/6 would simplify to 4/3. And c would just remain as that negative 1/3. Let's go over the page, but from there we found the values of g, f and c, and we want to get the centre and radius. So for that, just remember the centre is given by negative g and negative f. So in this case, if g is negative 2/3, then negative g would be negative 2/3, which means you would just have 2/3. The value of f is 4/3. So if you have the centre being negative f, it would be negative 4/3. So that will be your x and your y coordinate. We've got the centre, we then need to get the radius. Woo! So the radius is given by the square root of g² plus f² minus c, once again. If you sub in the values of g, f and c, you will end up with the square root of negative 2/3, all squared, plus 4/3 squared, take away negative 1/3. From there, if you square the negative 2/3, well, square a negative will give you a positive. But to work this out, just do 2/3 times 2/3, or really you're squaring the 2 and you're squaring the 3, which will give you 4/9. Square the 4, you get 16, square the 3, you get 9, and remember you're adding the 1/3. What you'll notice though is that you have something over 9 plus something over 9 plus 1/3. So you may wish to change the 1/3 into ninths. To change 1/3 into ninths, just multiply the numerator and denominator by 3. Doing that, you will then have plus 3/9. If you do that, it makes the next bit so much easier. So from there, if you just add the fractions together, Calissa, what would you get? Brilliant! You would get 23/9. And from there, you could leave it as that. But really what that means is it's the square root of 23 divided by the square root of 9. And we all know the square root of 9 is 3. Brilliant! So you could just write it as that. So that is going to be the radius of that circle. Let's move on. Example number 4. So this time we've got x² plus y² equals 4 and x² plus y² take away 8x plus 6y plus 24 equals 0. They are both equations of two circles. Yeah. Find the centres and radiuses, and hence find the shortest distance between their circumferences. So we need the radius, we need the centre, so let's take the first circle. x² plus y² equals 4. We need the centre and we need the radius of that circle. This is what we did in lesson 1. Valley, what's the centre of that circle? Good, it's just 0, 0. Brilliant. Remember, if you have the equation of a circle and it's x² plus y² equals a number, then the centre is just 0, 0 when it's x² plus y². R squared is then going to be 4, which means then that r is going to be 2. You got it. Whoops, I've not got it. From there then, you can look at the second equation, so x² plus y² take away 8x plus 6y plus 24 equals 0, and again you can write down the centre and the radius. But because this is in the general form, you may wish to first of all write down the values of 2f, 2g and c. So in the order, 2g first of all is the coefficient of x, so you'd have -8. 2f is the coefficient of y, so you'd have 6. And c, the number on its own, is 24. Have 2g and 2f, so g is -4, f is 3, and c would be -24. Nothing changes with that. From there, the centre is given by -g, -f, so you'd have -4, which is +4, and -3. That is the centre of that circle. The next circle, you're thinking, right, well, this radius, it's not as simple as r² is 4. For this one, we have to use the formula, the square root of g² plus f² minus c. Subbing in the values then of g, f, and c. Remember, g is -4, so it's the square root of -4², plus 3², take away this 24. Work that out and you get the square root of 16 plus 9 take away 24, which is the square root of 1, which is just going to be 1. So we know the radius of the second circle is going to be 1. The next thing we have to do is find the shortest distance between these circles, between their circumferences. And for that, you may wish to go off to the side and sketch what we've already got. So with the first circle, we've got the centre as 0, 0, and we know the radius from the centre to the outside, there is a distance of 2. So we know that distance is 2. For the next circle, we've got the centre 4, -3, and we know it has a radius of 1. What you're asked is for the shortest distance between these two circles. Obviously, the shortest distance is not going to be going from here away up to here, or from here away around to here. No, no, no. The shortest distance is obviously this straight line between them. So how would you go about working out that shortest distance? What would you need to know first of all? How would you do it? Adam, what do you think? Good, you would need to work out the distance between the centres. And then if you had the distance between the centres, what could you do, Adam? Good, you could take away this radius and you could take away this radius, and what you'd be left with is just this wee bit that is in pink. So, first of all, work out the distance between the centres of the circle. So, centre 1 and centre 2 squared. The distance between them squared is going to be, and really you're using the distance formula, so you're going to have 4 take away 0 all squared plus -3 take away 0 all squared. From there, 4 take away 0 all squared is just going to be 4 squared, which will give you 16. And that -3 take away 0 is -3 squared, which is 9, meaning then the distance between these two circles squared is going to be 25. But we want to work out that actual distance, so square root it, and we would end up with 5. So we know the distance between them is just 5 units. Adam, what did you say? Good. From there, if you know then that the whole distance from here right the way down to here is going to be 5, you can take away this wee bit here, you can take away the 2, take away the 1, and what you're left with is just this short distance between them. So, the shortest distance between them is just the distance between the centres minus the sum of the radii. So you'd have 5 take away this 2 plus 1. That'll leave you with 2 units. So, this distance between them, the shortest distance, will just be 2. Well done. Next one. Example 5. 3 circles touch externally as shown. So the circles are just touching and no more. They're definitely not overlapping. The centres are collinear. What does collinear mean, Sammy? Good, they lie in a straight line. Perfect. And the equations of the two smaller circles are given by these two equations here. So you want to then find the equation of this large circle, this big circle. How could you do that then? What would you do? Well, for this, what you probably want to think is, well, because you're given the equations of both circles, you could work out the centre of both of these smaller circles. If you're given the equations, as well as working out the centre, you could also work out the radius. So we could work out the radius of this circle and the radius of this circle. You want to, though, work out the equation of this bigger circle here. That is what you're wanting. So if we know the centres, first of all, and we know the radius, well, you could do something similar to the last example. You could work out the distance between centre 1 and centre 2. And then if you take away both radii, well, you'd be left with the diameter of this circle. The centre of this circle, we're going to have to maybe do a different way. But let's just start this question off and see what we get for the radius and the centre for these smaller circles. So first of all, taking x² plus y² plus 20x, take away 16y plus 139 equals 0. Remember, you may wish to go through writing down 2g, 2f, c, and then halving 2g and 2f to get g and f, and then you'll have c as well. But remember, you can half the coefficient of x, half the coefficient of y, and that will give you the centre of this circle. If you have those values of g, f, and c, you can then work out the radius. So just go off to the side, write down g, f, and c. Sub them in here, and you'll get the square root of 10 squared plus -8 squared, take away 139, which will then work out to be the square root of 25, which is 5 units. So we know the radius of this circle from here to here is going to be 5 units. Second circle, do the same thing. So we've got x squared add y squared, take away 28x plus 48y plus 747 equals 0. So the centre of that circle, again, take the x coefficient, half it, and change the sign, and do the same for the y. So you'd end up with 14 and negative 24. Take the values of g, f, and c, again at the side, write down 2g equals, 2f equals, c equals, half 2g and 2f, and from there you can sub that in to this equation here. So the radius will be given by negative 14 squared plus 24 squared, take away 747, which will then work out to be the square root of 25, which is 5. Mamma mia! If you're looking at it, then this is also 5. So we've got a radius of 5 here, and we've got a radius of 5 here. What that means then is that this centre of this circle is going to be halfway between the centre of this circle and the centre of this circle. What would you use then to work that out? Brilliant, you could use the midpoint. Good. So we can use the midpoint to get the centre, and we can also use their knowledge of the distance from the centre here to the centre here in order to work out the diameter. So let's do those two things. So for this circle, we know then the centre of the circles, and we know the radius of both circles. Let's go, first of all, working out the distance between centre 1 and centre 2. So really you're using your distance formula for that. So you're subtracting the x values and squaring them, and then you're adding that to subtract the y values and then square them. That will give you then 14 take away negative 10 all squared, plus negative 24 take away 8 all squared, which gives you 24 squared at negative 32 squared, which will then give you 1600, meaning then this distance between the centres, you will square root that to end up with 40. You know then that the diameter of this larger circle, as I said on the last page, because this radius is 5 and this radius is 5, and you know the whole thing from here right the way down to here is 40. So what you can do is you can take the diameter of the larger circle to be that 40, take away this 5 and this 5. And if you do that, you will obviously get 30. So we know the diameter of this larger circle. Woohoo! Happy days. From there then, what's the radius of that circle? 15. Good. Everybody's saying it. You're just halving the diameter. Brilliant. Again, what it said is in the last page is because you know this is 5 and you know this is 5, well, the centre of this large circle, circle 3, is going to be the midpoint of these two centres. So you can say then the midpoint formula can be used. So you're wanting to then add the x's and then half them, add the y's and half them, and that will give you the centre 2, negative 8. So that is the centre of this circle. From there then, we know the centre of that circle. So we know the centre, we know the radius of that circle, so you can sub that into your formula. The formula that you would use is x minus a all squared plus y minus b all squared equals r squared. That will then give you x minus 2 all squared plus y take away negative 8, which is y add 8 all squared, and that would equal 15 squared. What you could do is you could square the 15, that gives you 225, and you could leave your answer as that. X minus 2 all squared plus y plus 8 all squared equals 225. What you may have to do sometimes though, is you may be asked to write it in that general form, the x squared plus y squared plus 2gx and so on. And if you are asked to write it in that form, you will then have to multiply out your brackets like that, and then simplify it, gather your like terms, and you're writing it in the form of x squared, x, y, your constant, and that would equal 0. So multiplying it out and simplifying it will give you that formula there, that equation. Let's move on to one more example. Example 6. Find the centre of this circle here. We've got the points P, negative 1, 1. We've got Q, 3, 3. And we have R, 6, 2. How on earth would we find the centre? Well, for this, you are going to have to use some previous knowledge. And the previous knowledge relates to perpendicular bisectors. If I drew in a vector, if I drew in the perpendicular bisector of PQ here, and if I drew in the perpendicular bisector of QR, well, obviously they're going to cross. But what magical point are they going to cross? Brilliant. they're going to cross at the center of the circle. So whenever you get a chord, if you draw in the perpendicular bisector, and if you have another chord and you draw in the perpendicular bisector, they will always cross in the center of the circle. So using that knowledge, that is what we had in the question, and we will have to work out the equation of each perpendicular bisector. So let's go first of all with PQ. If you're wanting a bit more depth or detail with perpendicular bisectors, look back to the lesson in chapter 1. But going over this very quickly, you'd first of all have to work out the midpoint of PQ. So add the x's half it, add the y's half it, you would get 1, 2. You would need the gradient of PQ, so y2 take y1 over x2 take x1 will give you a half. But remember, it's the perpendicular gradient you want. So flip this upside down, change the sign, and the gradient of, I'm going to call that line 1. I'm just going to call this line 1. That will be negative 2. From there, you can get the equation of that line by doing y2 to y minus b equals m bracket x minus a. Use the midpoint for that, it's the only point that you know, and use the gradient of negative 2. Sub them in, and you will end up with 2x plus y equals 4. So that will be the equation of this perpendicular bisector. Do the exact same thing for QR, so Q and R, using the midpoint formula. Basically add the x's and half it, add the y's and half it. You will get the midpoint to be 9 over 2 and 5 over 2. To get the gradient of QR, you'd have y2 take y1 over x2 take x1, which will give you negative 1/3. Remember though, it's the perpendicular gradient that you want, so the gradient of this line, I'm going to call that line 2, will then be 3. And once you know the gradient, once you know the point, you can sub that into y minus b equals m bracket x minus a. If you do that and you work your way through it, you'll end up with negative 6x plus 2y equals negative 22. To go from this step to this step, all I did was multiply out the brackets, so I had 3x and then negative 27 over 2, and then multiplied every single term by 2. Doing that gave me the 2y take away 5 equals 6x take 27, and then I'm just gathering those like terms. You've then got these two equations. You've got equation 1 and equation 2, and really what you want to do is you want to find the point of intersection. How, Lily, could you go about finding the point of intersection? What would you use? Brilliant! Simultaneous equations. Ooh, yes. So, solving these simultaneously will give you, well, what you would have to do, I'm sure you'll be absolutely fine with this, but really you've got both equations. All I'm doing is I'm trying to get the same number, the same coefficient of y, but the negative. So I'm multiplying the first equation by negative 2 with every single term. That gives me negative 4x take away 2y equals negative 8. And then after that, I've got negative 2y here and 2y here. So I'd add the x terms, add the y terms, and add these constants together. So negative 10x is negative 30, and x would then be 3. Sub that into one of the equations and you'll get the y value. Once you get the y value and the x value, sub them into the other equation just to double check, make sure you have not made any mistakes. And then you can say that the x value will be 3, the y value will be negative 2, meaning then the centre of the circle will be 3, negative 2. And that will be your answer. Obviously, these questions towards the end are a bit trickier. Try the ones at the start of these exercises and then build up to that. But it's the Maths in Action book, page 172, exercise 3A and 3B. Good luck! It's a general equation of a circle. Have fun. Woo! Bye. How.